Today we will be looking at pyrite, an alloy of iron and sulfur commonly known as fool's gold. Pyrite has been used to help start fires in manufacturing sulfuric acid and sulfur dioxide, and juxtapositionally was used as an ignition for early guns and has been seen as a healing stone by some. It is an isometric cubic crystal system. The Fe2 plus ions form an FCC lattice while the sulfur ions reside on the 1-1-1 axes. With the closely packed FCC lattice structure comes strength, ductility, high melting point, and thermal and electrical conductivity. Pyrite is formed naturally and obtained through mining. It is a lime compound, so it can only be made at one concentration of sulfur and iron, that being 66.5% sulfur and 33.5% iron between 0 and 730 degrees Celsius. A lower sulfur concentration creates a pyrrhotite and pyrite phase, while a higher sulfur concentration creates a pyrite and liquid phase. Heating above 730 degrees creates a pyrrhotite and liquid phase. It can be made a single crystal with no defects and is not metastable because the equilibriums can be reached within a timely manner. Pyrite has a density of 4.8 grams per centimeters cubed and a melting point of 1,177 to 1,188 degrees Celsius and is composed of 2 atoms of sulfur and 1 of iron, with the iron-sulfur interactions being mainly covalent. Bond length is 0.2262 nanometers and 328.9 kilojoules per mole. 3 defects are possible. The first is vacancy defects, which cause compression and tension. This defect reduces the conductivity enough so that it can't be used for things such as solar panels. Another common defect is twin boundaries. This makes pyrite often sold as a decoration due to the interesting geometric structure it creates. Finally, mass transport of sulfur occurs through the iron interstitials because the sulfur atoms are small enough to diffuse through the interstitial spaces of the iron FCC. Thanks for listening.